We are going to review carbohydrates and lipids. With carbohydrates, there are two different types of groups, aldoses and ketones. The difference between a monosaccharide, a disaccharide, an oligosaccharide, and a polysaccharide. The order you have put together, the larger your chain will be. Monosaccharide meaning one, polysaccharide meaning many. Now there's different things that happen. Let's refer to the picture down in the bottom left-hand corner. First, you have polysaccharides, such as a bagel or something, which is a high starchy type of compound. After you eat that bagel, it goes down to your stomach where it could be broken down into things like disaccharides and oligosaccharides. Eventually, it is broken down to a monosaccharide where it can then be absorbed in your body and brought to your liver. From there, those monosaccharides can be made into different types of things. Extra sugars can be stored as glycogen, or it can be carried to your fat in the form of glycerol and stored as fat molecules. The additional sugars are used to store in used as an energy source for your muscles. So if you don't use up all your sugar and you have some left over, it will be stored as glycogen in your liver. When glycogen stores are used up, the additional will go to your fat. So as you can see, there are some here that you need to be familiar with. Glycolysis is the conversion of glucose into lactase and pyruvate. Gluconeogenesis, meaning the production of new glucose, is making glucose from non-carbohydrate sources. Amino acids, glycerol, and lactate, that happens more with starvation. Glycogenolysis is the breakdown of glycogen to glucose. Glycogenesis is the conversion of glucose to glycogen. And lipogenesis is making fat. Lipolysis is breaking fat down to be used for energy. Some important things to know about carbohydrates. Well, let's talk about the regulation of the metabolism. There are certain hormones that can control your glucose levels in your blood. Glucose is the only usable carbohydrate that is used from your cells by your cells as energy. Insulin is the only one that can decrease your blood sugar. Okay, so I'll circle him. That will decrease it. Other hormones that increase glucose include glucagon, epinephrine, and glucocorticoids, growth hormone, and adrenocorticotropic hormone, thyroxine, and somatostatin. The only one that decreases it is insulin. So from there, let's look at a couple different types of diabetes. First one being diabetes mellitus type 1. With this, you will have antibodies to the B cells in your pancreas, cause an absolute decrease in insulin. We will find increased ketones, weight loss. Now, type 2 diabetes, you will have an insulin resistance. You will have weight gain, and you will not have the ketone production. Another type is gestational diabetes. This is the type that you get when you are pregnant, if you're fortunate enough to get it. Well, at the top here, I have a box talking about diabetes diagnosis. Usually what happens is a mom goes to the doctor's office at about 24 weeks, and they'll give her a 50-gram load of glucose that they drink, and then draw their blood an hour later. Well, if her level is over 130, they will, if it's higher than that, they will go ahead and do a 3-hour glucose tolerance test. The 3-hour glucose tolerance test has to meet 2 out of the 4 values as you see above in order for it to be consistent. The symptoms of hypoglycemia would be those of somewhat like a drunk person. So trembling, stupor, cognitive issues, not making much sense. They may even be completely passed out. So it's very important to differentiate between finding someone on the street corner if they're drunk or if they just have a diabetes issue. The hexokinase method is widely used to test glucose oxidase. We also do glucose on serum and spinal fluid, urine and spinal fluid. Spinal fluid is very important to make note that if you have a decreased glucose in your spinal fluid, it could mean you have meningitis. The normal reference range for glucose in the bloodstream is 70 to 110. I'm going to go ahead and put that on here, so it's very, very important to make note of. (70 to 110 milligrams per deciliter). Spinal fluid is a bit lower. Other tests that we do is a glycosylated hemoglobin or hemoglobin A1. After a good indication of what the blood glucose has been over the last 2 to 3 months. Another thing that we test for is ketones. We will find ketones increased in the blood in times of carb depression. Microalbuminuria is done in diabetics quite often to make sure that having those high levels of glucose over time hasn't done damage to the kidneys, where we would find small amounts of albumin in their urine. Autoantibody is an antibody to the beta cells in the islets of Langerhans in the pancreas. When that happens, it destroys those islets where insulin is usually secreted, and therefore they become destroyed, and you do become a type 1 diabetic at that point. Okay, moving into lipids. The roles of lipids include their rich energy source. They're a very efficient way for your body to store extra calories, as we learned about. If you eat too much sugar, it can still be stored as fat. Also an integral part of cell membranes and plays a structural role. So we have different types of foods, and they have different lipid compositions. A fatty acid is a major constituent of triglycerides and phospholipids. Triglycerides are the main oil inside the body. Phospholipids are amphipathic. They like to become liquid and kind of become part of it. They don't float on the top like traditional lipid would, and they have a phosphate group on them. Cholesterol is different in that it's not an energy source, and it's usually used in the body to make hormones as well. So the different types of lipoproteins are what we test for in the body quite often. The first one, chylomicrons, which we don't test for, but it carries triglycerides, and we do test for the triglycerides. Well, chylomicrons, when you have a very, very lipemic sample, they're very large, so it actually gives that creamy color to like these samples that you see on the right-hand side of the screen. Very low density lipoprotein carries triglycerides from the liver to the peripheral tissue. VLDL can be broken into LDL, low density lipoprotein, and that can cause atherosclerosis when it's increased too much. Now, in order to do an LDL, we have to do the Friedewald calculation. Now, we can do some expensive beta quantification, but the Friedewald calculation is what's commonly done in laboratories. To do a Friedewald calculation, you take the LDL, the LDL equals the cholesterol minus the HDL minus triglycerides, that's 5. Very important to make note of the fact that if your triglycerides are greater than 400, as you can see over here, greater than 400, you cannot do this Friedewald calculation. A couple other types of things to make note of. Apolipoproteins. Too much is undesirable. It can lead to coronary artery disease. And sphingolipids are a lipid membrane bilayer that protects cells. So we can enumerate those to kind of tell what type of lipid we're dealing with. A type of hypoalpha-lipoproteinemia is Pangiers disease. With this, we have a very decreased high-density lipoprotein, which is our good fat. A decreased good fat is not a good thing because it is responsible for carrying our lipids back to our liver. So you have extra cholesterol and things floating around, it will grab those and bring them back. An HDL of only 1 to 2 could classify you as having Pangiers disease. You do need to be familiar with the reference ranges for lipids. You need a cholesterol less than 200, HDL should be 40 to 75 or higher, LDL and triglycerides should be 60 to 150.